Hello everyone. So here I have framed a new question, completely new question, brand new question for IIT JEE as well as Olympiad aspirants, and this question is made by clubbing three concepts, two of physics and one of mathematics. Physics concepts are of projectile motion and wave optics, whereas the concept which I have used from mathematics is of conic section parabola. Let's see. So the question says that a projectile fired obliquely from a point on the ground, the firing instant is t equals to 0 and it again reaches the ground at t equals to capital T. Now in its path passes through 2 points P and Q, and they have given the time instants as t1 and t2 respectively for these two. Now at the points P and Q of the path of the projectile, what we have done, we have now placed two coherent sources, and these are simultaneously emitting waves of wavelength lambda. And if I want the waves to constructively interfere at the focus of the projectile's path, then what values of lambda are allowed? And I have taken n as the order of the maxima. Since constructive interference, so maxima. Okay, so I would like that you can simply pause the video and type in your comments which option you think out of the four is possibly correct, and then we will proceed with the complete solution, detailed solution. So I hope you have done that. Let's start. So the three concepts, first of all, I'll quickly say the concepts that we are using. First off, projectile motion, which you all should be aware of, that if we have a parabolic path of a projectile and taking the vertical as y-axis, uy being the initial velocity y component, then t equals to 0 the firing time, t equals to capital T the time of flight is given as what? 2 uy by g, right? Next thing, if we take any point on the path of the projectile and height is h and it is supposed at t equals to t, so this height h is given by uyt minus half gt squared, right, where t lies in between 0 and capital T. So this is one concept. The second concept, wave optics, or in general interference of waves when we talk of. So what concept we know, that here they are saying the sources are placed at point P and Q, and the path difference where the interference occurs, that is at the focus, let's call it as f. So this we can write as the difference of the lengths traveled. So from point P to F and Q to F, we'll just have to take the difference, bigger minus smaller, right? PF minus QF. And since they are saying constructive interference, so we can equate this to what? N lambda, right? Where N is the order of the maxima, which we can take as 1, 2, 3 and so on. You cannot take 0 here because the 2 points are at different time instants, so their distance from the focus may not be same. Now, the third concept which we are using from conics, which everyone should be aware of, that when we have a parabola and this being the axis of the parabola, if this is the focus and we take any point, say P, on the parabola, you take the distance of P from the focus and you draw a line perpendicular to the axis, which is called as the directrix of the parabola. So it has a very important property. If you draw a normal from P on the directrix, so Pn and Pf both are equal because the eccentricity of a parabola is 1. So Pf is always equals to Pn. P is any point on the path of the projectile, here it is parabolic, and Pf, distance between point and focus, and distance from the directrix. So these two are equal. So now we are aware of the three concepts that we are going to use. So now let's quickly move on and see how to solve this particular question. So I have already drawn this diagram where you can see that this is the path of the projectile and this is the directrix we have drawn. This is the focus, these are the 2 points P and Q, and I said that P point is reached at time t equals to t1, O t equals to 0, A point for time of flight capital T, which we know is 2 uy by g, correct? Now when we say at the point P, this height let's call it as h1 and this height let's call it as h2. For Q the time given is t equals to t2. So what we can write first? H1 can be written as ut minus half gt square, using that uy t1 minus half g t1 square, right? And similarly, can I write H2 is equals to uy t2 minus half g t2 square. Clear? Now you see that if I take the total height of the directrix from the ground, above the ground, as capital H, so we can say that this particular height will be what? It will be h minus h1. Now this being the normal, let's call this as n1, and this point let's call it as n2. So this distance will obviously become h minus h2, and this is h minus h1. So as we discussed the property of parabola, so pf will become equals to pn, so this distance will be automatically equals to h minus h1, and this distance will be equals to h minus h2, right? So now if you see, the distance from focus of the point P is more than that of Q, so the wave which will come from P to focus and the wave which will come from Q to the focus, we can say the path difference due to these waves at the focus will be simply PF minus QF, and since we have constructive interference, this should be equals to n lambda. Now what is the difference of PF and QF? If you subtract both, you can see capital H will be cancelled. So here we will be left with simply H2 minus H1 will become equals to n lambda. So they were asking the possible values of lambda. So we can simply write lambda is equals to H2 minus H1 upon n. So if I subtract H2 and H1, what we are going to get? Let's see. Lambda is, I can take 1 by n common outside, H2 minus H1 first term, uy t2 minus t1, right? And minus g by 2, we will get t2 squared minus t1 squared. I hope it is clear. So now let's see. You can see that uy was not given in the question, but capital T, the time of flight, was given. So can I substitute from here the value of uy as gt by 2? So uy can be written as gt by 2. The moment I write uy as gt by 2, so g can be taken common. G can be taken common. What else can be taken common? 2 can be taken common. N can be taken common. What will be left here? Here we will be left with t and t2 minus t1. And here we will be left with t2 squared minus t1 squared. Now if you see, something else will come common. What is that? t2 square minus t1 square is t2 minus t1 into t1 plus t2. So t2 minus t1 also comes common. So g t2 minus t1 by 2n comes common, and what is left inside is capital T minus in bracket t1 plus t2. So this is the expression for lambda, and for various values of n, where I already said that n can have integral values 1, 2, 3, 4 and so on. So these are the allowable values of lambda. So I hope you found this question interesting, and if we see the option, we can see that the first option itself is the correct one, and I am sure that many of you would have got this as the correct option also. So stay tuned for such interesting questions, such innovative questions, which I will be continuously posting, and I need your support so that you just subscribe, listen to these videos and give your valuable inputs and comments. If you want any particular topic, discussion, shortcuts required for any particular concept, you can write that too in the comments. So that will be all for today. Thank you.